Alright guys, this trek into DIY tech is going to be about robots, specifically about the Sumo robot. Back in the days when I was running a makerspace and subsequently a robotics club, we started getting into sumo robots and other types of fighting robots. And I created a video to show the details of this guy. It's called the Red Bison. And I created a video to show what this guy did and how it worked. What I'm going to do is I'm going to update that video and give a few more details on this robot and all of its features, because there have been a lot of upgrades since its inception back then. So yeah, we're going to just go through that, and I'll show you the hardware as well as the software that went into making this guy work. Alright guys, I've got some random targets here set up so you can see how it works. And I'm just going to set them to 0, which is the default, and turn them on. There's the startup tone, and then 3 seconds. So now he starts to search. There you go. So he'll start his search movement. When he comes to the border, it's white, so he steps back. So this one's just outside of the range of the ultrasonic, so he's gonna do that and then start searching again. So on 1, it was a very slow movement because I had it set up to teach the other roboticists. And so you can see how he does his search pattern there. But anyway, that is one of the So that is just one of the 6 different starting modes that it had, and that was all driven by the potentiometer. All right, now I'm going to set it up on 1 so you can see what the difference is between the two different movement modes. So we're set to 1, 3 seconds. Caught a little bit of sight of it. So right now, if the other robot had been moving, he would have been in the beam sooner. And so that's it. You're done there. So all right, so I'm going to set it to mode 2. So this is mode 2. 3 seconds. And you see how that's different. He backs out of the way. So if your opponent's going straight in every time, now he's backed out of the way. So now I'm searching a lot quicker. And there you go. He's done. He's done. He doesn't know he's done. I gotta let him know. There you go. You're done, man. So another important thing to keep note of when you're putting these systems together as well is, how am I going to test all this stuff? So I actually have a sketch that helps to test the ultrasonic side of it, but you can see here the LEDs light as soon as there's something in front of it. So hopefully you can see that LED going there, and they all do that. So I'm able to test to make sure that the whole system is working before I go to competition. I also have a in there, I don't know if you can see this, this is glowing red right now, which means that the program is halted, and that I can start and stop it from here. So I start it, you get 3 seconds, he's on automatic, and then if I press this again while he's running, it'll put him back in standby. So right now we're in standby, but also checking the battery level. So I know if the battery's too low to go into competition, because I'll get an indication here on the LEDs. And again, we'll, as I keep saying, go into the software and you'll be able to see that. Okay, you see this chassis here? This is the standard chassis that we used to use in the robotics club. And it's a chassis from Pololu. I'll put a link in the description as well for that. And this chassis was just a generic chassis that they have for robots. They supply a lot of components for robots, a lot of circuit boards, sensors, motors, and things like that. But this was a chassis that was very popular for making Sumo robots because it was very easy to implement. Tracks, it was pretty heavy, and you can have different gear ratios in here. Batteries were easy to load up, and so it was used a lot for Sumo robot competitions. And so we just adopted this one as it was pretty easy to get going with it. So as you can see here, if you're familiar with the Arduino Uno, you can see the footprint right there. See the headers right there. So you guys know exactly where that board plugs in there. And you know, we'll take Red Bison apart and show you in greater detail. Okay, so any technology that's sufficiently advanced looks like magic. So I'm going to show you now. I'm going to show you how the magic works. This guy, like I said, goes together with an Arduino board. And so what I did to get all of this up here, which you normally wouldn't do something like this where you have a mechanical structure hanging off of a PC board. You would rather have it the other way, with a PC board supported by mechanics. But in this case, this is sufficiently light to where these robust headers down here can hold all of that up. So what we're going to do first is we're going to just go ahead and pull these wires out of the headers. And so just pop those out of there so that you guys can see. And these are just solid core, and I have this documented so I can put these back in when we're done here. But we're just going to pop those out for now so that I can get the Arduino board off of there and show you how that all goes in. So see how easy that is to get those out of there. And now we just walk the Arduino board off the pins, and so she comes off just like that. So you can see this is the same as that other Sumo base that I showed you before, but only this one has the addition of the female headers as well as the male headers. So the male headers, Arduino board gets plugged in there. Female headers break out these same pins up, so I have access to the Arduino connections through here for my additional circuitry that's up on top. There's also you can see the array of IR sensors here. This is how it was sensing the white portions of the ring so that it didn't go outside of the ring. And again, you know, the significance of the white portions of the ring and the starting strips and all of that, you can see that in the Sumo competition rules, how all of that's laid out. But for our purposes, these sensors keep us from going outside of the ring by sensing the white strip. And then the controller board is plugged into this Sumo base. So that's that, and you can get different colors of these. I got the red ones, obviously, to match the rest of Red Bison. So here you can see, here's our Arduino Uno. And electrically right now, this guy is not connected to anything on this side. So if you can see, it all goes through the Sumo chassis. These plug into the female headers, and the male headers plug back into the Uno board. So I just have these nylon screws here securing the Uno board to this plastic base, and that's just PLA that I've printed. So now what I'm going to do is I'm going to unscrew this, and I'll show you what that board looks like under there. And these are just Philister head screws. I like to use those because the head of the screw is, the diameter of the head of the screw is very small. So, and also because they're plastic, I find that the slots don't strip out as easily as the Phillips screws, because we're always getting into this board. So you can see there I have nylon spacers to account for all the wiring that I've got under here. And so let me pull off that spacer so I can show you the board underneath. There goes the screw. Take all these guys out. So this is a lot finer than, because it's all basically signal wires, you can get away with a really small gauge wire. And so this is magnet wire, basically, with different colored magnet wire, so that I can keep all the signals straight. Yeah, this is just this is what you call point-to-point wiring. In the Adafruit board, I put them side by side so you can see. In the Adafruit board, I actually used some of the traces the same way that you would use in a breadboard. You can see there, there's less wire going across, but I was restricted to, using these going across instead of just free-forming it. Where here, I was able to free-form everything. I just put the sensors wherever I wanted, and I made the connections point to point with the wire. So yeah, that's it. That's how all of that goes together. And there you go. Okay, now that you've seen all that, I'm going to show you how to get into the software and start programming your Sumo, I was going to say. So yeah, let's go through and take a look at the sketch. And if you're familiar already with the Arduino Uno or any of the Arduino boards, you'll be familiar with most of what I'm going through. If you haven't seen it before, this is a really cool microcontroller that you can use in your DIY projects, and they're fairly easy to learn how to program. So here we go. Okay, it's raining pretty good outside, as you can probably hear. So this is a good time to go through this, I guess. So check this out. I'm just going to highlight things. I'm not going to go too deep into this because, again, this video is just to give you an overview, slightly more detailed than the original video, so you can see how all of this is laid out. And what I'm going to do is I'm going to go into preferences, and I'm going to make the font a little bigger so you can have an easier time of viewing it. Boom. Alright, so this is the Arduino IDE, and it's just an integrated development environment. and you can get it online. If you go to Arduino, they have a lot of good resources here. They have the hardware set up there, the store where you can buy your Arduino. So they have a lot of good things on here, and we're using the Arduino Uno right now. So we have that one set up. Now to get the software, so you're just going to go to your software tab, and when you download the software, they ask you if you want to make a donation. I usually do, just to keep everything going. You know, we all use this stuff, and they're working hard to keep it going. They do have the store these days, and so that's offset by that. But yeah, I make a donation whenever I can. This is the Pololu site for it. So this is where you would get the hardware, and so it's the Sumo Shield. This is a really good resource because you go here, and you have, as well as the schematics and 3D models. So when you're making the plastic part of your Sumo robot, you can go there and get a 3D model that you can model your plastic onto, so you have a base to work from. This is and you also have in here where to get your libraries for your Arduino IDE. So that's all right there. So now let's get to the software, as I had been promising before. So in Arduino, you always have void setup. So all of this in here is to set up your variables and anything that has to be in a preset condition before you get started. So for example, opening move select, which is the potentiometer that I was using to tell the Sumo robot which opening move to use every time we go for a round, is right here, as well as the battery level. So all these are variables that you are using to pass information. Like you store all of this. These are all temporary, so meaning when you shut off the robot, all of this goes away. So this is just your temporary memory. This is not long-term storage. All the sensors are here. So left, right, and aft proximity sensor, and as well as the ultrasonic sensor. So I'm gathering all that information there. And then I also have a debug port set up, so I can plug in serially and pull information through the debug port. So if we're plugged in USB, you can go here, serial monitor, and you can see information coming back. So now I have a lot of places where I'm checking the sensors, for example, and you want to just wave your hand in front of it, and the sensor will report back. Well, I'll give you an example here. So here's a serial print line that says move and pause. So anytime I set it up so that the tracks are off the table, and I just let him do his thing, and anytime he feels like a pausing or stopping his motion, he'll send out a movement pause, and then we'll see that on the serial monitor. So you can really check the whole program, what it's doing, using that method. And again, I'm not going to go through all the programming, all the tools and things that you use while you're programming, because this is just a quick overview. So again, so when you have the void setup is there, the next one that you go to is going to be void loop. right? So I have all of the moves set up there, and maybe we need to zoom back out. Hold on, we'll zoom back out because this is probably really too close to get a good picture of everything that's on there. So we'll go back out to that. So we'll go back to where we have our void setup started. So this is void loop. Void setup is right above it. Void loop is anything between these brackets will continuously run. So all of this up until the closing bracket will continuously run. This is check edge. So this is our check edge subroutine. We check the edge. If the sensors on the bottom come up to the edge, it does this. So this is the ultrasonic range rangefinder. A long distance. So this is a long integer that we're using. Okay, without getting into the math, let's not get into the math. This just tells me how far away the opponent is in front of me, and then behavior is going to be different depending on how close we are. And you can see that, you know, in the demo that we just looked at, the closer something was, the stronger the reaction was, and that just makes it so that, you know, if somebody's making an arc around you or something like that, if you're really close up, you want to get in there and push them immediately, versus if they're far away, you don't want to waste your energy and get yourself into a position where you're at the edge of the ring if you don't need to, so you move up on your opponent slower. At least this is what the strategy that I was using here. So these are the opening moves. So you can see here what I did was use a conditional jump, and so the conditional jump makes it so that, so you can see here, the conditional jump based on the resistance in the potentiometer, that resistance is scaled between 0 and 255. It's scaled so that I only have 6 measurements, like 0 to, you know, divide 255 by 6, and that's the range that the potentiometer hits. From here to here is 0, from here to here is 0 to 1, and so forth. Yeah, and I started at the logical numbers. I mean the logical numbers, so not the physical numbers. So I use the logical 0 as number 1. So seek mode. This is the routine that allows us to pan back and forth and find your opponent with the other sensors. So you're really not using the ultrasonic sensors in this setup. I'm using the IR sensors, and whenever there's a ping on one of the infrared sensors, it actually sets a flag up and it tells it to spin around X amount of degrees, which should put the ultrasonic sensor, which should put the opponent in the ultrasonic sensor's view. So that also depends on, you know, so if there's a detection on the left sensor, we'll spin around 90 degrees to the left. Detection on the right sensor, we'll spin around 90 degrees to the right. And if there's a detection in the aft sensor, we'll spin around 180 degrees. So the idea is to get some quick motion going in the direction of the detection, and then the ultrasonic sensor takes over and creates the push out of the ring. So I know I haven't been going, so this is the IR detection, left, right, and we have the aft detection, which I have them all broken out so that they can be, I can put them in the sequence that I want the robot to check. So I want to check from behind first, from the left, and then from the right. And so there's a strategy to that. It takes longer to turn around 180 degrees, and so I'm checking, and it's harder to counter a move from behind because it's easy to roll forward if somebody's pushing you. So I have the aft detection happening first, and these all break out. Again, if it detects anything in one of these three directions, it immediately goes to jumps back to the forward facing sensor, and it gives control to the forward facing sensor. So the other thing is this loop here. As soon as you start up, you don't want him to take off, right? Because the start of that particular round in the match is signaled by the referee, and then you want the 3 seconds to go. This is how we do that. Unless the button's pressed, this just is in an infinite loop. Once the button's pressed, then we do 3 seconds and break out to the rest of the functional part of the loop. And that's it, really. I mean, it's a very it's not very long. We've only got 372 lines in this thing, and it does all of that. So hey, I hope this encourages you to be able to get in there and try some of this. Alright, so that's what goes into making a sumo robot, at least the ones that we used to use in the robotics club. They're they can be fairly complex or very simple. Ours were middle of the road, but yeah, this video has been a long one. Thanks for watching all the way to the end. I always appreciate that. Any questions, put them in the comments, and I'll try to get to them, as soon as I can. See you in the next one. Man, they stripped the rims off of that one quick, didn't they? Ooh, they didn't even put it up on blocks.